Power. Power is the rate at which work is done. It's how fast you do the work. Okay, so it's not how much work you can do, it's how fast you can do that amount of work. Myself and somebody else might both be able to do 100 joules of work, but I can do it in 5 seconds and they can do it in 10 seconds. That makes me more powerful because I did it faster. Okay? So again, power is how fast you can do the work. So it's work divided by time. Now work is measured in joules, amount of energy over the amount of time. Okay? Symbol is the letter P. The units are joules per second, which we call a watt, and it is a scalar. So let's go ahead and take a look at these two equations. We're going to start out. We said power is how fast you can do the work. So it's work over time. Well, we know that work is equal to force times distance times the cosine of the angle between the direction the object moves and the way the direction the force was applied over time. Now, let's, for the sake of simplicity, say that the angle between the direction the object moves and the force that's applied is 0 degrees. So the cosine of 0 is just 1. So we're just going to get rid of that for simplicity's sake. Okay? So power is equal to a force times distance divided by time. Well, let's group these together. A distance divided by a time, we know that as a speed. So power can also be written as a force times a speed. So we are going to have two equations for power. First one, power is work or energy over time, and the second one, power is equal to force times speed. Now let's talk about some conceptual things here. Okay? We've seen the unit watts before. Okay? You've seen that unit probably written on the side of a light bulb package. Okay? Now whether you've got the old light bulbs or the new light bulbs, probably says something with watts. Maybe it says 60 watts. You've got the old one, it actually is telling you about how many joules are burned per second. If you got the new one, it's kind of giving you an equivalent for brightness. We're going to talk about this. Say you've got a 60 watt light bulb and a 100 watt light bulb. Okay, what that means is in a 60 watt light bulb, there are 60 joules of energy being spent every second. Okay, so that means every second your light bulb's on, 60 joules of energy have been used. If you've got a 100 watt light bulb, it means that you are using 100 joules of energy every second. So a couple of things. One, this one's going to burn brighter. Okay? It's burning more energy per second, so therefore it's going to burn brighter. And that's kind of why they still label the packages with these watts, even though they're not accurate with the new light bulbs with the exact amount of energy they're using. Because people know a 100 watt light bulb, they expect to have a certain amount of brightness as compared to a 60 watt light bulb. But what else is this telling us? Well, I'm using 60 joules per second here. I'm using 100 joules per second here. When the electric company bills me, they bill me for the amount of joules or how much energy I've used. Okay? So I'm going to spend more money. This is going to cost more. Okay? So a little bit of an application there. Another application. Okay? Because units are watts, but you think power, maybe you think horsepower. Okay? So let's pretend we've got a car that has 130 horsepower. And then we've got another car, and this car has 200 horsepower. Okay? This does not mean, and horsepower, again, is just a different unit. Okay? Watts were a power unit over here. Horsepower is also a power unit. Okay? It's just a different unit. Okay? So horsepower. We've got 130 horsepower. We've got 200 horsepower. Well, 130 horsepower. That car can still get to the top of this hill. Okay? Both of these cars can get to the top of the hill. They can both do the amount of work required to get there. The difference is this car has the ability to do it faster. Okay? So it doesn't make doesn't give you the ability to do more work. It just simply gives you the ability to do the work that you're going to do faster. So this car would get to the top of the hill faster.